The ocean floor trembles as explosives rip through ancient bedrock. Engineers watch nervously. They're attempting the impossible. Off China's coast, a 20 billion gamble is unfolding, building an international airport where only waves exist. What happens when human ambition collides with the full fury of the South China Sea? The answer will shock you. Heat, crushing humidity, the edge of East China's Fujian province. Here, a megastructure is rising from the sea itself. This is Xiamen Xiang'an International Airport, or rather where it will stand. Because right now, the land doesn't exist yet. Look at these blueprints. A Class 4F international hub, two 3,800-meter runways, a terminal spanning 660,000 meters, all designed to process 62 million passengers annually. There's just one problem. You can't build on water, or can you? This is the story of humanity's relentless push against natural boundaries. The Chinese government has allocated $20 billion, but insiders whisper the true cost could reach $35 billion. Money alone can't solve what these engineers face. Typhoons with winds exceeding 200 kilometers per hour regularly batter this coastline. The seabed is unstable. Nearby, Taiwan's Kinmen airspace creates political complications no engineer can solve with equations. Yet failure is not an option. Drone shot pulling back to reveal vast ocean area marked with buoys. What you're seeing is the future. But first, engineers must challenge the ocean itself in a battle where the sea has every advantage. The mission is clear but unprecedented. Reclaim 5 square kilometers of land from the ocean depths, create solid earth where fish once swam, then build one of Asia's largest aviation hubs on this artificial ground. Close-up of project director looking concerned. "We're not just building an airport," whispers a senior engineer who asked to remain anonymous. "We're redefining what's possible, but at what cost?" What these workers are about to attempt will either revolutionize coastal construction forever or become a 20 billion monument to human hubris. To understand the true scale of what's happening here, you need to see it from above. This vast blue expanse, it will disappear. In its place, an island built by human hands. The operation begins with one of the largest land reclamation projects in human history. These titans of industry, dredging vessels larger than football fields, run 24 hours a day, 7 days a week. Each ship can move 35,000 cubic meters of sand in a single day. For perspective, that's enough to fill 14 Olympic-sized swimming pools every single day. But there's a dark side to this efficiency. Marine biologists have documented the disappearance of 3 local fish species since dredging began. The government reports claim minimal environmental impact, but satellite imagery tells a different story. A plume of sediment now extends 15 kilometers into once pristine waters. The clock is ticking. The political deadline looms over every worker on site. Time-lapse of sand being pumped onto site day by day. The map of Yemen is being redrawn by human hands. Sand erupts from massive pipes like volcanic magma, building new earth meter by meter, but raw sand alone would collapse under the weight of a single aircraft. Let alone the A380s this airport is designed to accommodate. Shot of trucks delivering rocks. An endless convoy of trucks delivers the rock needed to secure the new CU wall. These boulders, some weighing as much as 12 tons, form the protective barrier against the relentless tides. Each one must be placed precisely according to computer models that took months to perfect. Close-up of exhausted worker wiping sweat under the scorching sun, where temperatures on the exposed reclamation site can reach 45 degrees ill. The foundation of a new world emerges. Workers collapse from heat exhaustion weekly. 3 have died since construction began, an uncomfortable statistic absent from official reports. But the greatest challenge isn't human endurance, it's physics. Animation showing subside and sand settles, it compacts, it shifts. Building a runway requires stability measured in millim, not centi. The solution, gravity itself. These 30-ton weights are dropped repeatedly from heights of 30 meters, hammering the loose soil into a solid base. The impact creates many earthquakes felt kilometers away. Local villagers complain of cracked foundations in their homes, but compensation has been minimal. What was once open is now kilometers of manufactured terrain, but it's still not stable enough. Engineer looking at problematic readings on monitoring equipment. We're seeing subsidence rates triple what we projected, admits a site engineer checking monitoring equipment. If this continues, the runway could sink unevenly after completion. The team has just discovered their first major setback, one that threatens to add billions to the already staggering budget. And the typhoon season is approaching fast. The question isn't whether they can build this airport anymore.
It's whether what they build will survive what nature has in store. The success of Xiamen hinges on what you can't see, what lies beneath. Shot of blueprints being unrolled. Before a single terminal wall can rise, an invisible battle must be won. Groundwater, the silent enemy of mega projects, threatens everything. Close-up of water seeping through sand. Water always finds a way, explains Chief Drainage Engineer Louis. Always. His team has one mission: keep the future runways dry during typhoons that can dump 0.5 meter of rain in 24 hours. Helicopter shot of massive drainage pipes being laid. These aren't ordinary drainage pipes. Each concrete channel is large enough for a car to drive through. The network spans over 120 kilometers beneath the airport, longer than the distance from Shanghai to Suzhou. But there's a problem no one anticipated. Workers in knee-deep water, looking frustrated. The reclaimed land is sinking faster than expected in some sections, creating depressions where water pools. Engineers scramble to redesign the drainage gradient, an adjustment that costs $30 million and delays the project by 3 critical weeks. Time-lapse of workers, installing drainage systems day and night. The work never stops. Shifts run 24 hours a day to meet the 2025 deadline, a date set to coincide with China's next 5-year plan announcement. Failure would mean political embarrassment no one is willing to risk. Close-up of welders securing drainage junctions. Every weld secures the safety of future passengers. Every joint must withstand the pressure of millions of gallons of water during monsoon season. One leak could undermine the entire foundation. Shot of workers in protective gear handling chemicals. What they don't mention in press releases is the chemical treatment. To prevent microbiological corrosion, the entire drainage system is treated with compounds that local environmental groups have protested against. The government's response: silence. Drone shot showing the scale of drainage installation. From above, it resembles the circulatory system of a concrete giant. Arteries and veins that will keep the airport's heart dry when the heavens open. Rain begins falling on workers as if on cue. The first storm arrives, not a typhoon, not yet, but enough to test whether their calculations hold. Close-up of anxious faces watching water levels. The drainage system has its first real-world test, and it's failing in the southeast quadrant. Alarm sounds everyone to Sector 7. Now the race against rising water begins, and the deadline clock keeps ticking. When building where no land exists, you need roots that reach the earth's bones. With the drainage crisis temporarily contained, the deep foundation work begins. These pile drivers, some standing 15 stories tall, will anchor the airport to the planet itself. Sound of rhythmic pounding as piles are driven. Each impact sends vibrations that can be a felt kilometer away. Thousands of miles, each driven 60 meters down until they hit bedrock. The percussion is deafening. Workers wear double hearing protection, but many will still suffer permanent damage. Steel cages reinforce the concrete piles, creating an unshakable root system. Each cage contains enough steel to build 50 cars, precisely arranged in patterns designed to withstand earthquakes up to magnitude 8.0. But nature has surprises in store. "This isn't what our surveys showed," mutters the head geologist. Core samples reveal an unexpected layer of soft clay 40 meters down, exactly where the piles need to find purchase. The redesign will cost hundreds of millions and weeks they don't have. Concrete flows into the earth in a non-stop operation. Temperature must be precisely controlled. Too hot and the concrete cracks as it cures. Too cold and it won't set properly. Specialized cooling pipes run through each pore. a technology developed specifically for this project. Workers testing concrete samples and field laboratory quality control is rigorous. Samples are tested hourly. There is no room for error. A single failed pile could compromise an entire section of terminal. Time lapse of pile field growing across the site. A forest of concrete pillars now lies beneath the surface, 56,000 in total. If placed end to end, they would stretch from Beijing to Shanghai, yet they remain invisible to future passengers who will never know what lies beneath their feet. Explosives being prepared in the northern section. Bedrock proves too stubborn for conventional methods. Controlled explosives are the only solution, a dangerous operation over unstable reclaimed land. Workers taking cover fire in the hole. The blast sends shock waves across the site. When the dust clears, crack has appeared in a previously installed drainage channel. Close-up of hairline fracture spreading. What starts as a hairline fracture could become a catastrophic failure under the weight of a fully loaded aircraft.
The team has 48 hours to fix it before the next concrete pour permanently seals access. Storm clouds gathering on the horizon. Meanwhile, weather satellites track a developing system over the Philippines. Category 3 strengthening on a collision course with Xiamen. Lightning flash. The race against both man-made and natural deadlines intensifies. No one mentions the possibility of failure anymore. It's no longer an option they can afford to consider. As dawn breaks over the East China Sea, the skyline changes forever. Shot of crane assembling silhouetted against sunrise. An army of tower cranes takes position, 123 of them more than were used to build Dubai's Burj Khalifa. Today marks the moment when Xiamen Airport begins to rise from its man-made island. Close-up of construction manager checking blueprints. Today we make history, says Zhang Wei, his voice barely audible over the machinery. He hasn't slept in 36 hours. The approaching typhoon has compressed their timeline. What should take a week must now be done in 3 days. Dramatic shot of first column being raised. The first steel column of the terminal rises, marking the vertical ascent of China's most ambitious aviation hub. It weighs 30 tons and must be positioned with millimeter precision. One mistake now will multiply through the entire structure. Workers applauding as column locks into place, but there's no time to celebrate. The tropical storm has accelerated, upgraded now to Typhoon Meiwa. Category 4 projected arrival 58 hours. Aerial shot of foundation revealing the scale from above. The true scale of the 660,000 square meter terminal begins to reveal itself. That's larger than 92 football fields combined. The main hall alone will be bigger than the Forbidden City's central axis. Close-up of architectural details on steel components. This isn't just any terminal. It is designed in the traditional Minnan Dugong style. Ancient architecture meeting modern engineering in a fusion that has divided critics. Some call it a masterpiece of cultural preservation, others a waste of structural efficiency. Engineers arguing over blueprints. The debate isn't just academic. The curved roofline thong style add $280 million to the budget and create wind resistance patterns that no modern airport has ever had to solve. Massive curved beams being lifted by synchronized cranes. These enormous trusses, each weighing as much as a blue whale, will form the iconic sloping roof. Lifting them requires perfect synchronization between 4 cranes, the margin for error less than 3 centimeters. Crane operator Song Min has been awake for 20 hours straight. His eyes burn, his hands shake slightly. On his shoulders rests a $15 million roof section that could kill dozens if dropped. Close-up of Song's determined face. The wind is picking up. Safety protocols say operation should stop at wind speeds above 35 kilometers per hour. Current speeds 32 kilometers per hour and rising. The project manager gives the signal to continue anyway. Tense moments as beam is slowly positioned. A difference of millimeters creates a perfect fit or a catastrophic failure. Song guides the massive section into place with the precision of a surgeon. Locked secure. The terminal grows. One massive component at a time. Welders working at height. Sparks cascading down. Sparks illuminate the night as the structure becomes one rigid body. These welders working 60 meters above ground connect sections that must withstand typhoon force winds for the next century. Typhoon Moa has strengthened again. Category 5. Now the outer bands will reach the construction site in less than 24 hours. The evacuation order comes through. All non-essential personnel must leave the island. Only a skeleton crew will remain to secure equipment, but the central hub, the heart of the passenger terminal, remains exposed, partially complete, vulnerable. Will 5 years of work and billions of dollars survive the coming storm? Or will nature remind humans of their limitations in the most expensive way possible? The project faces its greatest test yet, and it isn't ready. 48 hours after Typhoon Meiwa made landfall, the damage assessment begins. Drone footage of construction site with debris miraculously, the main terminal structure held, but the cost was still devastating. 3 tower cranes toppled, materials worth $70 million destroyed, and the schedule already compressed, now impossible to maintain. Close-up of project director making phone call, a call to Beijing. The 2025 deadline cannot be moved. Additional resources will be deployed, but the message is clear. Failure is not an option. Time-lapse showing rapid acceleration of construction. What happens next defies conventional construction timelines. The workforce doubles overnight. 25,000 workers now swarm across the site in 3 shifts. Prefabricated sections arrive by sea, a floating supply chain that never stops. Workers installing massive prefab wall sections. Speed is essential. Prefabricated sections accelerate the build. What would take weeks to construct on site now locks into place in hours. The terminal grows visibly by the day, engineers testing wind resistance of facade panels. But this isn't just about speed. The terminal must withstand the next Meiwa and the next 50 after that. The glass facade is tested against winds of 300 kilometers an hour, plus a 20% safety margin. Each panel costs more than the average Chinese worker earns in a year. Close-up of specialized bolts being installed. Securing the facade against typhoon force winds is a top priority. These bolts, made from a titanium alloy developed for China's space program, cost $400 each. The terminal requires 175,000 of them. Shot of curved roof being completed. The distinctive curved roof line of the dong style is now visible from the air. But beneath its traditional appearance lies cutting-edge technology. Layers of high-tech insulation will keep the terminal energy efficient. Despite Fujian's punishing summer heat, workers installing environmental systems, the lungs of the airport, ventilation systems capable of completely replacing the air inside the terminal every 12 minutes, are carefully routed through structural elements. 100 kilometers of ducting, enough to reach the stratosphere if stretched vertically. Electrical workers pulling cable through conduit. Kilometers of cabling will power everything from lights to baggage belts. Enough copper to circle Fujian province runs through these walls. But there's a global copper shortage and prices have tripled since planning began. Project accountant looking at budget figures in red. The cost overruns are now impossible to hide. The $20 billion budget has been surpassed with no ceiling in sight. But it's too late to turn back. Night shot of partially completed terminal lit up for night work. As darkness falls, the work continues under floodlights. The terminal glows like a lantern on its artificial island, a beacon of human determination. Worker discovering hairline crack in structural element. Then a discovery that sends shockwaves through the project management team. The eastern wing is settling differently than predicted. The difference is small, just 7 millimeters. But in airport construction, that's an earthquake-sized problem. Engineering team gathered around monitoring equipment. The question no one wants to ask is the land reclamation failing beneath them. While the terminal battle continues, attention shifts to what will ultimately define this airport's success: its runways. Aerial view of the 3,800-meter runway strips marked out. 2 parallel strips, each 3,800 meters long, 60 meters wide, long enough to land the largest aircraft ever built, wide enough for the worst crosswind scenarios. But first, engineers must create something most take for granted: perfectly flat ground, close-up of surveyor with laser equipment. We're working to a tolerance of plus or minus 3 millimeters over the entire length, explains Chief Surveyor Lin Mei. That's like balancing a marble on 8 kilometers of glass without it rolling. Her team measures every square meter multiple times daily, tracking the subtle shifts of the reclaimed land beneath. Heavy machinery laying aggregate base layers. The paving begins with an elaborate dance of machines. Layer upon layer of crushed stone creates a stable roaded that must support aircraft weighing up to 575 tons, the equivalent of 300 SUVs landing at 270 kilometers per hour. Workers checking temperature gauges on asphalt. This surface must endure temperature fluctuations from 10 degrees Celsius in winter storms to plus 70 degrees Celsius under the summer sun. Special polymers imported from Germany give the asphalt flexibility without sacrificing strength at 20 times the cost of standard road materials. Close-up of precision paving machine. Perfect smoothness isn't a luxury, it's a safety requirement. The slightest bump could cause catastrophic damage to aircraft landing gear. Temperature is monitored constantly to ensure proper bonding between layers. Problem: material delivery barge stuck in storm disaster strikes. The barge carrying specialized runway materials is caught in a storm off Taiwan, delayed by 3 days. The paving schedule synchronized with curing times and weather windows collapses. Project managers arguing over solutions, the choice: wait for the correct materials or substitute with inferior alternatives available locally, wait and miss the deadline, substitute and compromise safety. The decision will haunt them either way. Shot of runway under construction next to the ocean. Meanwhile, the apron where planes park is built with high-strength concrete that must support stationary aircraft, where all weight concentrates on small contact patches rather than being distributed across moving wheels. Workers installing expansion joints. Expansion joints prevent the concrete from cracking under the hot sun. These seemingly simple gaps are engineering marvels. They must be exactly the right size to allow for thermal expansion while remaining perfectly flush to prevent damaging aircraft. Engineers testing surface with specialized equipment. The specifications are merciless. The difference in height between adjacent concrete slabs cannot exceed 1.5 millimeters, about the thickness of a credit card. Anything more could damage aircraft tires costing $25,000 each. Complex network of runway lights being installed. Thousands of lights are embedded in the runway surface, each one capable of guiding pilots through zero visibility conditions. The electrical system powering them has triple redundancy. If 2 systems fail, the third keeps planes landing safely. Testing water truck spraying runway to check drainage. The first drainage test reveals a problem. Water pools near the runway intersections. A low point of just 8 millimeters, invisible to the naked eye but potentially catastrophic during heavy rain. Night shot. Workers frantically grinding down high spots. Through the night, teams work to correct the imperfection, grinding down high spots millimeter by painstaking millimeter. The deadline clock keeps ticking. Weather radar showing another system developing. And in the Philippine Sea, another weather system begins to organize. Nature isn't finished testing China's ambitions yet. Inside the terminal, a different kind of marathon begins. Shot of vast, empty terminal space echoing with construction sounds. What looks like an aircraft hangar will soon process tens of thousands of passengers daily. But right now, it's a shell, a canvas waiting for the complex systems that make a modern airport function. Workers installing massive baggage handling system. The circulatory system of the airport is installed first. This baggage network, 18 kilometers of conveyor belts driven by 20,300 motors, will handle 40,000 bags per hour. One engineer describes it as a city's worth of mailrooms condensed into a single system. Close-up of autonomous sorting robots being tested. Automated sorters will handle millions of bags with robotic precision. But there's a software integration problem. The Chinese-developed AI doesn't communicate properly with the German-built physical systems. The error rate is 4.6% acceptable in most industries, catastrophic for baggage handling. Programmers working frantically at computer terminals. A team of programmers works around the clock to rewrite interface protocols. They have 14 days before the system must be operational for testing. Several haven't seen their families in months. Shot of check-in counters being installed. The check-in halls take shape, designed to welcome 62 million passengers annually. That's the equivalent of processing the entire population of Italy each year. But the marble flooring imported from Italy arrives with hairline cracks in 40% of the tiles, close-up of damaged Italian marble. The supplier blames rough handling during shipping. The construction team blames quality control. With no time to order replacements, a decision is made to use the damaged marble in less visible areas. A compromise that saves the schedule but wounds the project's prestige. Workers polishing floors to mirror finish. Despite the setbacks, floors are polished to a mirror finish, reflecting the grand ceiling inspired by ancient Chinese palace architecture. The effect is stunning, a blend of imperial grandeur and modern efficiency. IT specialists installing server infrastructure, digital systems are brought online, the brain of the airport waking up, 5,000 security cameras, 3,000 flight information displays, all managed by an AI system that can identify suspicious behavior or recognize passengers who need assistance. Security team testing facial recognition systems. The facial recognition system undergoes stress testing. It can process 100,000 faces per hour with 99.7% accuracy. A technological marvel with concerning privacy implications that go unmentioned in press releases. Landscapers bringing in tropical plants. Jim is a garden city and the airport reflects that identity. Thousands of plants, many rare species, create indoor gardens. But the air conditioning struggles with the added humidity, creating condensation problems that threaten electrical systems. Water dripping onto junction box, causing sparks and near disaster. Water droplets find their way into a primary power distribution node. The resulting short circuit blacks out half the terminal for 6 hours. Backup systems failed to activate properly. Emergency meeting of project leaders. With the opening date just months away, the punch list of problems grows faster than solutions can be implemented. Something will have to give. But what? 2 years after the first explosive charges reshaped the seabed, the moment of truth approaches. Air traffic control tower silhouetted against dawn sky. The air traffic control tower stands tall, the eye that watches over all. From this 65 meters high vantage point, controllers will orchestrate the dance of the skies. But first, they need to be certain everything works perfectly. Controllers running simulation tests. For 3 weeks, controllers have been running non-stop simulations, preparing for every conceivable scenario. Engine failures on takeoff. Multiple aircraft emergencies, complete power loss. The stress takes its toll. 2 controllers have already quit. Fuel trucks delivering to underground storage tanks. Massive fuel reserves are prepared to power the fleets. Each underground tank holds enough jet fuel to fill an Olympic swimming pool. Fuel is delivered directly to the gates through underground pipes, a system that eliminates fuel trucks on the tarmac but creates new safety challenges. Engineers testing emergency fuel shut-off systems. If these emergency shutoffs fail during a fire, the entire airport could become an inferno within minutes. The test results are concerning. Response times are 1.8888 seconds longer than international standards require. Security team conducting breach simulations. State-of-the-art security ensures safe travels for everyone. In theory, during breach testing, a security consultant successfully accessed the runway undetected, exposing a blind spot in the camera system that cost $2 million to rectify, cleaning crews polishing every surface. The construction dust is cleared, revealing the jewel underneath. In the final days before testing, an army of cleaners works through the terminal. No detail is too small. Even air vents are individually wiped clean. Dramatic shot of runway lights activating at dusk. A moment of magic. The runway lights pierce the darkness for the first time. 16,000 individual lights create a power path of stars leading to Xiamen. The effect is breathtaking. Visible from space, radar operators tracking test aircraft approach. The first test flight approaches. Years of hard work culminate in this single moment. An Airbus A330 on final approach. The pilots volunteering to be the first to land on this man-made island. Tense faces watching monitors in control tower. Every sensor is monitored, every system scrutinized. The slightest anomaly could abort the landing. Wind shear alerts flash on the controller screen. The reclaimed land creates unexpected air currents near the runway threshold. Pilot's perspective of final approach, too late to abort. The pilot commits to landing despite the warnings. The moment of truth has arrived. Shot of aircraft wheels. Touchdown, touchdown, the concrete holds. The landing gear remains intact. The construction passes its ultimate test, cheering in control room. But the celebration is premature. As the aircraft taxis toward the terminal, something unexpected happens. Close-up of aircraft wheel creating unusual depression in taxiway. The taxiway is deforming under the weight just slightly, just enough to send alarm bells ringing through the engineering team. The land beneath may still be settling. 6 months after that first test landing, passengers flow through Xiamen International Airport. Time lapse of terminal filling with travelers. The digital heart of the airport beats strong. Check-in kiosks process travelers in seconds. Baggage disappears on conveyor belts to emerge precisely at the right carousel on the either side of the world. The architecture stands as a tribute to men and heritage while housing technology from the future. Passengers admiring the architectural details from disaster to triumph. The story of Xiamen Jiangan embodies China's relentless drive. But at what cost? Quiet shot of memorial plaque for workers who died. The official death toll, 5 workers lost during construction. Unofficial estimates from labor rights groups place the number closer to 20. Their names do not appear in the gleaming terminal. Engineers still monitoring settlement gauges. Beneath the surface, the challenges continue. Settlement rates have stabilized, but engineers will monitor the reclaimed land for decades. Some sections still sink by millimeters each year, an acceptable rate, but a reminder that the battle with nature never truly ends. Shot of high-speed train arriving at airport station. Connected by metro lines 3 and 4, the airport links seamlessly to the city. The journey from downtown Xiamen now takes just 27 minutes, a technological marvel that masks the human cost of acceleration. Final aerial shot pulling back to reveal the entire airport. By 2030, 62 million people will pass through these gates every year. 1 million tons of cargo will flow through here, boosting the economy of China's southeast coast. From the ocean depths to the skies above, the transformation is total. Shot of subsidence monitoring equipment showing warning lights. But nature has the final word. The latest measurements show unexpected movement beneath runway 2. The margin of safety remains adequate for now. Engineers watch, they wait, they wonder. Plane taking off into sunset. As the sun sets on Xmongan, one question remains unanswered. In the endless contest between human ambition and natural forces, who will ultimately prevail? Aircraft disappearing into clouds. This engineering colossus built on borrowed land against impossible odds stands as both triumph and warning. A 20 billion gamble that redefined what's possible while revealing the limits we have yet to overcome.